Okay, so from your reading, basically all you need to know is that a stationary point occurs when the derivative of a function, so dy and dx or f dash x, is equal to 0. Alright, that's when we have a stationary point. This is either a maximum or minimum, and you can read about the difference between a global max and a global min, and a local max and a local min. In the textbook, those definitions are listed there, so you can have a look at those if you're unsure. So what we're going to do is question 1 here, and then we're going to talk about how we can find stationary points for y equals x to the power 3 plus 3x squared manually. So firstly, question 1 here, the tangents at point A, B and C are horizontal. Yep, that's definitely true. So that means they're stationary points. It wants us to classify them, okay? So we can see that A is a local maximum point. It's not necessarily the maximum point on the graph, because we can see that going on forever. Point C is also a local minimum, and point B is a stationary point of inflection. Okay, draw a sign diagram for the gradient function f dash x. Okay, so it wants us to find to draw a sign diagram for f dash x. Now we're not told the function, so we can't necessarily do that, but we do know the connection between when it's increasing and when it's decreasing. So we're going to have to look at this function and see that it's increasing for x is less than minus 2. Alright, so I'm going to draw the sign diagram underneath here. We can see it's increasing for x is less than minus 2, which means on the derivative graph this is positive. Okay, then it's decreasing from minus 2 through to 3. Okay, that's all decreasing. Now there might be some special value about 0 because it's a stationary point of inflection, and then of course between 3 and 5, well, after 3 it's just continuously increasing. So that's a sign diagram of f dash x, and obviously we can state intervals for which it's increasing, and then it wants us to draw a sign diagram of fx for all of x. Okay, now if we look at how we're going to find stationary points for a function like this, basically what we're going to do is find dy on dx and then find when dy on dx equals 0. So the derivative of this one is 3x squared plus 6x, and we can see if we're going to make this equal to 0, we're just going to need to factorize it. Okay, a common factor is 3x. That leaves us with x plus 2 equals 0. So either 3x equals 0 or x plus 2 equals 0. So x equals 0 or x equals minus 2. What does this mean? It means stationary points occur at x equals 0 and x equals minus 2. So on this original function, these are either local maximum or minimum points. We'll need to look at the graph to determine which they are. So hopefully this is fairly simple. Again, all we're doing is finding the derivative and making it equal to 0. This is where a maximum, a minimum, or stationary inflection point occurs.